To one and all, my name is Sheikh Muhammad Iqbal. Today I am going to explain a topic on Gauss Seidel method, and I am gonna solve a problem on the Gauss Seidel method. Let us know about the Gauss Seidel method. In numeric linear algebra, the Gauss Seidel method is also known as the Liebman method or the method of successive displacement. It is an alternative method used to solve the system of linear equations. Let us consider the system of equations as a1x plus b1y plus c1z is equal to d1, a2x plus b2y plus c2z is equal to d2, a3x plus b3y plus c3z is equal to d3. Assume that the coefficients a1, b2, c3 are diagonally dominant. Now rewrite the above equation as x is equal to d1 by a1 minus b1 by a1 yn minus c1 by a1 zn, y is equal to d2 by b2 minus a2 xn by b2 minus c2 y1 yn by b2, z is equal to d3 by c3 minus a3 xn by c3 minus b3 by c3 yn. By the method of the formula of Gauss-Seidel method, we can write as x n plus 1 is equal to d1 by a1 minus b1 yn by a1 minus c1 by a1 zn. Yn plus 1 is equals to d2 by b2 minus b2 by a2 by b2 xn plus 1 minus c2 by b2 yn. Zn plus 1 is equal to d3 by c3 minus a3 by c3 xn plus 1 minus b3 by c3 yn plus 1. First we put n is equal to 0, where n is equal to 0, 1, 2, 3. Initially we assume x0 is equal to y0 is equal to z0 is equal to 0. x1 is equal to d1 by a1 minus b1 y0 minus c1 by a1 z0. y1 is equal to d2 by b2 minus a2 by b2 into x1 minus c2 by b2 into z0. z1 is equal to d3 by c3 minus a3 xn plus 1 by c3 minus b3 by c3 yn plus 1. Then we simplify this as x1 is equal to d1 by a1, y1 is equal to d2 by b2 minus a2 by b2 x1, z1 is equal to d3 by c3 minus a3 by c3 x1 minus b3 by c3 y1. Similarly, put n is equal to 1, 2, 3. Continue this process until the differentiation is negligible. Let us solve a sum on the Gauss-Seidel method. Given the equation is equal to 10x plus 2y plus z is equal to 9, 2x plus 20y minus 2z is equal to minus 144, minus 2x plus 3y plus 10z is equal to 22. Arranging them in the order of diagonally dominant, given then 10x plus 2x plus 2y plus z is equal to 9, 2x plus 20y minus 2z is equal to minus 144, minus 2x plus 3y plus 10z is equal to 22. Clearly they are diagonally dominant. Then we can write as x is equal to 1 by 10 of 9 minus 2y minus z, y is equal to 1 by 20 of minus 144 minus 2x plus 2z, z is equals to 1 by 10 of 22 plus 2x minus 3y. We have a formula by Gauss-Seidel iteration formula. Xn plus 1 is equals to d1 by a1 minus b1 yn by a1 minus c1 zn by a1. Yn plus 1 is equal to d2 by b2 minus a2 xn plus 1 by b2 minus c2 by b2 zn. Zn plus 1 is equal to d3 by c3 minus a3 by c3 xn plus 1 minus b3 by c3 yn plus 1. Initially let us assume that x0 is equal to y0 is equal to z0 is equal to 0. Put n is equals to 0. By putting n is equal to 0, substitute the 0 in the equation. By evaluating the values in calculator, we get x1 value as 0.900, y1 value as minus 7.29000, z1 value as 4.56700. Now substitute y1 in b. By putting n is equal to 1, we get the second approximation. x2 is equals to 1.90130, y2 is equals to minus 6.93343, z2 is equal to 4.600666029. By put n is equals to 2, the third approximation, x3 is equals to, we get 1.82066 minus 6.91604 as y through 3. z3 is equal to 4.63894. Put n is equals to 3, the fourth approximation, x4 is equals to 1.81931, 6.91804 as y4, z4 is equals to 4.63927. Next, put n is equals to 4, we get fifth approximation, x5 is equals to 1.81968, y5 is equals to minus 6.91804, z5 is equals to 4.63935. As we get the differences of x4 and x5 are negligible, so the exact value of the roots are x is equals to 1.81968, y is equals to minus 6.91804, z is equals to 4.63935. It is the required value. Thank you for giving me this opportunity.